Today we are moving on with trigonometry. The thing about trigonometry is that there's so many units. I've tried to split this course into 3 of them, but there's actually unlimited amounts of them, and they're all related in some way. I will relate the 3 of them together as well as I can. All of them depend on today's note in some way. So this is an important note to maybe put a little star beside so that you know to go back to it. So this is Unit 3. In this course, Unit 3, Unit 4, and Unit 5 are all trigonometry. And this particular note is about radians and degrees. You should have experience with degrees from grade 11, and you may have experience with radians. So there are multiple measurements of temperature, for example, Celsius and Fahrenheit, and this is similar. So you are okay with degrees, but maybe you're not okay with radians. You might be okay with Celsius, but maybe not okay with Fahrenheit. You need to be able to convert between the two and at least know one of them really well. So today's note is about that, and one other topic, which is another topic that will rely on degrees and radians, but it's called reference angles, and that will last the length of trigonometry as well. So back to the first page, the conversion. I think the conversion is quite simple as long as you can keep it straight. And I will refer to these links in a minute. These links are available on the Google site, and I will take you to them just briefly now, just so you can take a look at them. But if I give you a degree measurement, which I kind of hope at this point you know that a degree measurement looks something like that with a unit measurement there. If I give you a degree measurement and I ask you to convert the degree measurement to radians, what you need to do is you need to multiply by pi over 180. Now I have put it in blue in the middle of all this red. You reduce the fraction, so you do have to deal with fractions in this unless something allows you decimal answers. And then after you're done, because you need a unit, you either tack on the word radian, radians, or you can use the abbreviation rad. If you need to convert from radians to degrees, then your conversion factor is the reciprocal, the upside down. So you multiply by 180 over pi, or 180 divided by pi. You should know that something is radians because there's a pi in it, and because the word radians falls after it, and you should know that it is a degree measurement when it has the little degree sign. So I'm going to show you a picture of what a radian is, because if you haven't had experience with it, it's good to have a little picture of what it is. So basically, and I can use purple, if I take any circle will have a center, and any circle will have a radius. It actually has unlimited amounts of radii, but if you pick 2 of them, so that obviously this length is equal to this length, because all radians are the same length, and then you have the exact same length sitting here, but on the curve, this space in here is called 1 radian. Then, if you do it again, that's a 2nd radian. Then, if you do it again, that's a 3rd radian. And in half a circle, not a coincidence, you have 3.1416 blah 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 radians. So you actually have pi radians in half a circle. So pi radians is equal to 180 degrees. That means you've got another pi radians down here. So in a full circle, which is 360 degrees, you have 2 pi radians. These are facts that you need to know off the top of your head. You do have the option of knowing others off the top of your head, sort of like your times tables. If you know them, some math is easier. So that's just a little warning for you. I'm going to get rid of all this stuff. Now to look at those websites, those links that I gave you. So I've got them open in Chrome. And the first one I'll look at is the top one, the Math is Fun. And this is a picture of what I'm talking about. So what it says down here, and I quite like this description. A radian is the angle that's made when we take the radius and wrap it around the circle. So if this distance is the same as this distance, if both of those are radii, and this crust on your pizza or pumpkin pie or apple pie is the same length, then you've created 1 radian as an angle. There is other information here. That's where I stole the picture. So pi radians is the same as 180 degrees. See how that has a unit measurement and this has a unit measurement, so we know what we're talking about. So this is a list, this is a list of handy facts. So at some point, you might accidentally memorize these the same way as you accidentally memorized how to write your own name or accidentally memorized your times tables. This is another site. This is the int math site. I like this for quite a few reasons. I'm not going to spend a lot of time here, mostly because I've been waiting a really long time. I don't know why this keeps happening. I've been waiting a really long time for this graphic to show up, and it just isn't. So hopefully if you open it and give this a read, your graphic will show up. It has something to do with the fact that this circle is 6 units for a radius, which means everyone is 6 units for a radius. And then when you make this blue curve 6 units curved, that you've created 1 radian of an angle. And the last link that I've left you, I really like this link because I like the fact that math comes from nature. So this is a little write-up about how math and nature, at least for degrees, work together fairly closely. So that might interest some of you. So I just leave those there for your interest only. What I'm going to do now is I'm going to take a break, set myself up with enough space and the right colors, and I'll come back and we'll take a look at each of these degree measurements, and we're going to write each angle that's in degree measurements in radians, and it says in terms of pi, which means pi has to be in our answer. So give me a sec. All right, time's up on my break. I am taking these 4 degree measurements and I am converting degrees to radians. So that conversion factor is this step, which means I have to multiply by pi over 180, which for me looks like this. So before I start doing any calculations, so I have the right color out or the same color out, I'm going to write times pi over 180 times pi over 180 times pi over 180, and finally times pi over 180. So I'm going to show maybe a few more steps with the first couple, maybe less for the next. Really, these are 1-mark questions. I'm going to take this and imagine that there is a 1 underneath the 15 degrees, which means I have to multiply across the top because that's how we multiply fractions. I can lose the degree sign, multiply across the bottom, and then, according to this step, it says reduce the resulting fraction. So I have to take 15 over 180 with a pi in it, and I have to reduce that. You can take as many or as few steps as possible. So I know I can divide by 5. and divide by 5 is 36. And then I can divide by 3, and I can divide by 3, and I get that as my reduced answer. You can totally go from the question to the answer if you have an ABC button on your calculator, or if you can just do this magic math all at one time. What is important is that when you get a radian answer, you tell me that it's a radian answer. So the next question, I don't want to put the 1 down. I don't want to write down the exact same thing looking like this, so instead I'm going straight to reducing. So I can't do this stuff in my head, so I'm going to take negative 12 pi over 18, so that's me dividing both by 10, and then I can divide by 6 and divide by 6. Feel free to do it in less steps than me, but make sure that if you are given a positive degree, you have a positive radian. If you're given a negative degree, you're given a negative radian. So if I go back to, I think it's the first site, maybe the second one. It says somewhere in here that anti-clockwise or counterclockwise is positive. So counterclockwise is opposite to the clock on the wall. It's positive, and you do have negative, which means they'd be clockwise rotations. So the next thing is this one. I'm going to, in my head, divide by 5. So divide by 5, divide by 5, divide by 5. And divide 180 by 5. Then I can divide by 3, I think. I'm going to totally cheat and use my calculator. My cell phone calculator is 47. Don't lose the pi. And divide by 3. And I can't divide that any further, so I get radians. And finally, the last one, I'm going to divide by 10. Divide by 10. Divide by 2, divide by 2, can't divide anymore, so slap on the radians. So these are the angles, 15 degrees, negative 120 degrees, 705 degrees, 80 degrees, written in terms of pi for each one. So the next one is writing each of these, oh my gosh, each of these angles in radians rounded correctly to 2 decimal places. So I'm going to move this down just a smidge. It doesn't matter if I ask you to write it in terms of pi or to write it as 2 decimal places. Your conversion factor is exactly the same. So I have to take each of these exact same questions as what we just finished and still multiply them by pi over 180. That's the only thing you're allowed to do. So give me a sec to write that in for each of these. And again, these are 1-mark questions. So I'm either going to give you the mark because you did it perfectly. There's no half marks. This is really a very simple calculation if you do it correctly. So I'm going to go back to the black pen, and I'm going to dig out my calculator for this. And I do want you to know there's 2 slightly different answers for these questions. I hope I can move this without doing too much damage. Okay, that's good. So with this question, I'm going to do 15 times pi divided by 180 on my calculator. And I'm going to get an answer rounded correctly to 2 decimal places. So 15 times 3.14 divided by 180, and I get 0.26166666666, so to 2 decimal places, 0.26. Now you'll notice that when I did that calculation, I didn't use the pi button, I used 3.14. I do have a pi button somewhere on here, there it is. Yours might be easily accessible, or it might be a second function. Either way, you can do it this way as well, so 15 times, hit my pi button, divided by 180, and I still get 0.26. I will do both calculations anytime I ask you to do this so that I have all the possible answers that you can have, just in case using all the extra digits of pi actually makes a huge difference, which sometimes it does and sometimes it doesn't. Either way, this answer is in radians, so you have to tell me it's in radians. And for the next 3 questions, I am not going to show my work. I'm just going to plunk on my calculator. I knew that was going to happen. Let's see if I move it this way. Okay. Can barely see it. So 120 negative times, I'm going to use the pi button this time, divided by 180 to 2 decimal places is negative 2.09. Just to check it out, for fun, 120 negative times 3.14 divided by 180 is exactly the same decimal to 2 decimal places. Next one, 705 times pi divided by 180. Is it me? There. So 705 times pi divided by 180 is equal to 12.30 radians. And just for fun, I use the pi button. 705 times 3.14 divided by 180 is exactly the same, but you can see how it's a little bit off when I don't use the pi button. Last one, 80 times pi, oh, I didn't get the 8. 80 times pi divided by 180 is equal to 1.40 rounded to 2 decimal places. Don't lose the units. That was with the pi button, just for kicks. 80 times 3.14 divided by 180 equals same thing, off a little bit. So it might affect your 3rd digit instead of your 4th digit after the decimal. Either way, you can ballpark these. So if you know that 180 degrees is 3.14, you know that this is in the realm of possibility. Because if 120 degrees is less than 180 degrees, then 2.09 should be less than 3.14, and you're good, ignoring the negative temporarily. So the last question before we use this for a purpose is this, and when I did this note, the font has a funny pi, so I just pointed to that and said, okay, we've got a funny pi. I'm going to dig out my pen and rewrite these, even though that might be just as funny. I also have the slashy fractions instead of the stacked fractions, which I don't think are as safe. So, I don't know if you noticed with this question, I have given you radians, and I'm asking you to write the angle in degrees. So that means that I'm asking you to work in the opposite direction. So this time we have to multiply by 180 over pi. So times 180 over pi times 180 over pi times 180 over pi times 180 over pi. So I'm going to do the first one in a safe way, meaning I'm going to put the 1 down and then I'm going to multiply across the top. and across the bottom. And what happens is that you have a pi on each level, so they cancel each other out because it's all multiplying and dividing, and you get left with 180 degrees. Given in radians, answer in degrees. But you should have already known this. This is one of those things that I said off the top that you need to just know off the top of your head. So be aware that there are some situations where you can show no work and just go straight to the very last answer. So this one, I don't know if you can notice that here's a top pi, here's a bottom pi. So all I have to do is 180 divided by 3 is 60 degrees. And some of you don't even need this to know that that is the direct conversion. Next question, pi top, pi bottom. So I can do 3 times 180 and I can divide it by 4. So 180 divided by 4, I'm going to do that first because it doesn't matter the order you do multiplying and dividing. So 180 divided by 4 is, divided by 2 is 90, 45. 45 divided by 3 is 135 degrees. Don't forget your units. And with this last question on this page, we can knock those pi's out. We can do 180 divided by 5, then times it by -2, or you can do -2 times 180, which is 360, and divide it by 5, and get an overall answer. Oops, color coding got botched there. An overall answer of 72 degrees, which I will not mark right because if your radians are negative, your degrees are negative. So I'm going to take a little break and I am going to come back with some new definitions and 3 questions. I just need to make 3 grids because all I've got is 1. Okay, all set to go with reference angles. This could be also called angles in standard position. But what we're going to talk about is, number 1, how to draw an angle in standard position or a reference angle. And also talk about related acute angles. So related acute angles, you don't have to write that down every time because there's this really, really inventive, imaginative acronym for related acute angles, and that is an RAA, all capitals. Related acute angles are related to the angle I give you. They are an angle and they are acute. And by acute, hopefully you remember this from grade 9 or previous to grade 9, that means, if you're talking about degrees, that means somewhere between 0 and 90. So 800 is not a related acute angle because 800 is not between 0 and 90. That also means that if I gave you, I don't know, -47 degrees, not acute. The reason it's not acute is because it's supposed to be between 0 and 90 degrees, not a negative value. So make sure you do know that. I'm going to give you a couple of little tidbits of information that you may or may not care about. I quite like this stuff. Your answers could be a degree measurement, it could be a radian measurement, and it is the distance that it is from the x-axis, either the positive x-axis or the negative x-axis. So we're talking about, and I'm going to draw you a little picture, and you may see this numerous times, your related acute angle is, because here's your x-axis, if your angle is in quadrant 1, your related acute angle is here. If it's in quadrant 2, it's here. If it's in quadrant 3, the distance from the x is there. If it's in quadrant 4, it's here. So what I like to say is it's going to be in 1/4 of the bow tie. So you're either talking about this, 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 or this. And just because you may want to refer to this or write it down, here's quadrant 1, here's quadrant 2, here's quadrant 3, here's quadrant 4. Now there's a reason why this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4, and this is what I think is pretty nice. So I'm going to do it on this particular picture just because it's blank. Way back in the olden days, and I don't mean like when I was a kid, or even when your grandparents or great-grandparents were kids, I'm talking about like caveman days. Way back in the olden days, people used to watch the sun for time because they didn't have clocks, they didn't have watches. So we'll get to this at some point, maybe this year, maybe if you take calculus. Certainly this is a life skill. North, south, east, west. So I'm assuming I don't need to tell you that the sun rises in the east and sets in the west. That is why this is considered 0 degrees, and why we rotate in this direction until it's nighttime. And I think it's pretty cool that math has some relationship to things we might use in our real life, as opposed to our classroom life, which is, by the way, also part of your real life. So I'm going to erase this, just because this is a note. I should call this X and Y. And I need to know if you can figure out where 800 degrees is. Is it in quadrant 1? Is it in quadrant 2? Is it in quadrant 3? Is it in quadrant 4? So can you figure out where 800 degrees is? And it doesn't have to be to scale, but 800 degrees should be in quadrant 1. And that thing I just drew is called the terminal arm. So what happened was I went around 360 degrees. I went around another 360 degrees, which actually makes 720 degrees. And 720 degrees is not quite 800. I need to go a little bit more, but not 90 up to here. So whatever this space is, that is the RAA. So can you figure out what that is? If you need the calculation, you can take 800 and you can take off any amount of complete rotations. So if I take 800 degrees and I subtract 360, I am at 440 degrees, which is not an acute angle yet. So how about I take 440 degrees, and it's been a while for that, hasn't it? How about I take my pen and rotate it so I'm not hitting that button. So if I take 440 degrees and I subtract 360 degrees, another complete rotation, I'm left with 80. And I keep doing that over and over and over again until, in this case, now, because 80 is acute. So I can say the answer to my question is that the RAA is 80 degrees, and that has drawn the reference angle, and I've told you the RAA, which is another name for a reference angle. So I'm going to move C out of the way, and I'm going to do negative 475 degrees in this spot right here. So give me a sec to set that up while I move stuff around. All right, all set up to go. So we have to figure out where to put our terminal arm. So can you figure out what quadrant to put it in? And I personally I can't ballpark it. It's not something I'm really good at. Some of you might have that incredible skill, but I'm not sure where it is. All I know for sure is that if I take 475 negative and I do what we did over here in green and I minus 360 degrees, I'm going in the wrong direction. I'm making this question worse. So if it's useful to subtract 360 degrees to take you in the direction of an acute angle, then do that. But another option, the only other option, is to take the value, so in this case, negative 475 degrees, and here's the calculator. So 475 degrees negative, and instead of subtracting 360, I can add 360. I'm going to show my work. And that's still not acute. It's negative, which is bad, and it's over 90, so it's doubly bad. So I'm going to take negative 115, and I'm going to add on another 360 degrees. It's on my calculator, so I can just keep doing it. And that's 245. So you should know where 245 degrees is. You should know that this is 0 degrees, because that's where the sun rises. This is 90 degrees. This is 180 degrees. This is 270 degrees. So that means that negative 475, negative 115, and positive 245, totally not drawn to scale, they are all the exact same measurements, and they sit in quadrant 3. Now, I'm going to draw this as negative 475. So that means I start at 0 degrees and I swirl around negative 360, and then I swirl to there. So that is negative 475 degrees. Technically, I guess I could have labeled this terminal arm as 800 degrees because that was my little swirly thing. The question isn't answered by 245, because 245 and negative 115 and 475, all of the above are not acute angles, and they certainly aren't in the bow tie. So if I'm in the third quadrant, I need to have this angle right here. This guy. So we have to figure out what that value is. And hopefully you can figure out that pretty easily. If this is 245 degrees, and this is 180, then subtracting them will give you the space in between. That's an acute angle, positive between 0 and 90. Now the thing is, I do want to give you one more tiny definition. And that is that with this particular question, and I may have to move this in a minute, with this particular question, let's go blue because I haven't used it, negative 475 degrees and negative 115 degrees and 245 degrees and a whole slew of others that are separated by adding or subtracting 360 degrees off of it are called co-terminal angles. Just so you know. Thank me when you make Jeopardy. So in this question, 800 degrees and 440 degrees and 80 degrees and a whole slew of other ones where you add or subtract on 360 degrees are coterminal angles. Now before we go on to the other question, even though I'm not saving this exactly as it is, I'm taking this information just because it bothers me, and I'm turning it into not quite the same green, but green. There we go. Now it doesn't bother me quite so much. All right, so the last question, trickiest question of them all. Do you know what quadrant 10 pi over 3 is in? Because the honest answer is I have no clue. And the reason I have no clue is because even though I can convert from degrees to radians and radians to degrees, I can't visualize radians. So what I do off to the side is I cheat. And this is mathematical cheating, not like you're going to get caught and kicked out of university, college, or trade school kind of cheating. I'm going to take 10 pi over 3, and I'm going to go back to this note, which tells me how to convert radians to degrees so I can picture this the way I am supposed to picture it. So that means I have to times by 180 over pi. So I'm going to do that here. 180 over pi. I should have known that, but I wanted to give you the visual. The reason I should have known that is that's how you get rid of the pi's, because one's on the top, one's on the bottom. I know that 180 divided by 3 is 60. 60 times 10 is 600. Or this is 1,800 divided by 3 is still 600. And that's 600 degrees. And this is all scribble land, so I don't care if you do this on your calculator, in your head, on paper. 600 is kind of useless to me. I'm not sure where that is. I'm going to minus off 360 so that I can get myself a coterminal angle. And that's 240 degrees. And I know where 240 degrees, and this is how exact you have to be, it's somewhere here. So not exact at all. So I've got that. If I'm doing my picture, I start at 0 degrees and I keep going around 360, and then I get to the 240 mark. So that right there is 10 pi over 3 radians. It's also 240 degrees, so over here on the side, I'm going to take 240, and this is just me scribbling. I don't have to show this work. It can happen on my calculator. So this is 240, this is 180, so I'm minusing them, and I get 60 degrees. And if you write down that your RAA is 60 degrees, I don't give you full marks, because this question was given to you in radians, so I need your answer in radians. So you have to go over to the side somewhere, or in your head, and you have to take 60 degrees and convert in the opposite direction. And get yourself, chop off a 0, divide by 6, divide by 6, pi over 3 radians. Now, how did I know that that was okay? Well, 60 is acute, so pi over 3 is going to be acute when you turn it into radians. So all this stuff is for your benefit or my benefit, and there's our picture answer. I'm pretty sure this is still good to go, but you can always check the Google site. Anyways, remember that this note goes on for all of trig, so keep it in the back of your mind, or I guess preferably the middle or front of your mind. That would be beneficial to you. Until next time.